Together yesterday, and we're going to look at just number 2 and number 3. So we'll do number 2 and number 3 based upon what you guys came up with yesterday. And I think most of you that kind of figured out you got to follow those kind of rules and then manipulate it later on where you have to add your double and triple bonds on. And the students are getting really, really good at that, and that's the whole object of doing these, is that you get accustomed, because at some point you don't have to refer to those steps 1 through 5. None of you probably have to, unless you're missing them, and then I refer you back to those steps that you'd have to do. Okay, so number 3, we would just, put in our phosphorus, and, I'm going to do number 2 first, sorry. So we'll do number 2 first. So here's the drawings for number 2. And then we add them all up. It's 8 electrons. I noticed some of you do not count and write the exact number out. And I think that gets you in trouble because then you don't know how many you need to finish up with. So make sure that you count them and have that represented somewhere. And so AS is in the middle, surrounded by your hydrogens. Then we go ahead and go through our system of writing this out, and we do our 3 pairs, and we've got 1 left over, so it can go off the middle, can't go off the hydrogen. So then when we rewrite it, okay, you didn't have to rewrite it, but this is what it would be when it's written with the lines like you had to do on earlier assignments. Okay, so by doing that one, we're going to have you look at this. So you'll click on this where it says molecular shape, and you'll click on model. Okay, and you'll remove all. So you should end up something similar to that. That's your central atom. Okay? So then what we're going to do is match it up like our dot structure. So when we look at our dot structure, we have 3 of these, that single bonds, and then we have a lone pair, it's called. So that's what we're going to do. We're going to put on our free, and then we'll put on our lone pair. And now we have the shape, looking from the side view, it looks like a pyramid shape. So the name of it's going to have pyramid in it. And when we click on the molecular geometry of the name of it, the name of it is trigonal pyramidal. So underneath your drawing on that, you're going to write in trigonal pyramidal. So you'll just type in trigonal pyramidal. Does that make sense? Does everybody see how I did that? Remove all, 3 single bonds. We have 1. That's why I said on your structure in the center one, you want to show your lone pairs, because it helps you determine the shape. And there's our shape. It's a pyramid shape, and now down below we got a triangle called trigonal pyramidal. Make sense? So we'll do one more. We'll do number 3. So on number 3, we'll go ahead and draw out what we have. So we got 5 electrons for P. Se is going to have 6. And hydrogen is going to have 1. So then we add those all up and we get 12 electrons. So P goes in the middle, and H and Se. We do our pairing. Outside now gets the rest of them, as many as they'll get. So now we have 10, and we got an extra pair that we can put in here. Now we need to stop, because now we have 12 electrons. So we look at before and after pictures, and phosphorus looks fine with its unshared pairs. Hydrogen has just the sharing pair, and then selenium has 3. 1, 2, 3. That's what it has here. And then over here, it's just got 2. And so we just want to make sure that we're going to get rid of one of these pairs. It doesn't really matter which one we get rid of. Okay? So we get rid of that pair, and they go in between. So if you look at, I got 1, 2 pairs and 1, 2 pairs. Good. Everything has 8. P double bond Se, bond H, with an unshared pair. So that's what you should have for 3. So then, you guys go ahead and do the shape of that. See, you guys go ahead and put that together if you haven't done that already. So put together your shape. So you have a single bond, a double bond, and a lone pair. Your shape is bent. See, now this unshared pair, what it does is it pushes these two shared pairs closer together, and it creates a bent shape. This is called the VS EPR theory, and then V stands for valence. E stands for electron, and then P is pair, and then R is repulsion, and then electron repulsion theory. So what I'd like you to do is just to go ahead and do the rest of them you need to do on that sheet. And then you have to write names for every structure, for all of them. So do that, and you guys have until about 15 to 20 after to get that done. And then we got another thing we're going to work on. Okay? I'll come around if you guys got questions on things.
Can I come help you, Brad?
Yep.